All right, welcome back. So we're going to start just by actually solving some linear systems. Okay, now there's all sorts of techniques. There's what's called Gauss-Jordan elimination, which you'll learn, which you could learn in this class, but that's not really the point for me. So I'm going to actually teach you guys how to do it using computer tools. So let's take a look at the system. So let's solve, and we're going to have x1 plus x2 plus x3 plus x4 equals 1. x1 plus x4 equals 0. 2x1 plus x2 minus x3 plus x4 equals 0. x1 plus 2x2 minus x3 plus x4 equals 0. Okay? So now, if we were teaching, in a linear algebra class, you would start by learning how to do what's called Gauss-Jordan elimination. And if you want to look that up, you're welcome to. So Gauss-Jordan reduction, where what you're first going to do is you're going to basically take this x1 and sort of add to all of these some version of this row in order to eliminate all the x1s. And then after that, you're going to get this x2 that you're going to have here, okay? And you're going to eliminate all the x2s, okay? And so on and so forth. So you get what's called an upper triangular system, and you can solve for all of these pretty easily. We're not going to do that because it's just not really what we're focusing on here. So what I'm going to show you how to do is I'm going to show you how to do these on the computer. First, what we're going to do is we're going to write this as a system. So I'm going to write this as a matrix. I'm going to have 1, 1, 1, 1, 1, 0, 0, 1, 2, 1, negative 1, 1, 1, 2, negative 1, 1, acting on, now I like to write it this way, x1, x2, x3, x4 equals 1, 0, 0, 0. Okay, so what is it that I'm doing here? I'm taking, so this first equation, x1 plus x2 plus x3 plus x4 equals 1, is thinking of 1 times x1 plus 1 times x2 plus 1 times x3 plus 1 times x4 equals 1. x1 plus x4 equals 0. That's 1 times x1. x2 and x3 get zeros. 1 times x4 equals 0. 2x1 plus x2 minus x3 plus x4 equals this 0. And then x1 plus 2x2 minus x3 plus x4 equals 0. Okay, so I'm going to write this as ax equals b, where a equals this matrix 1, 1, 1, 1, 1, 0, 0, 1, 2, 1, negative 1, 1, 1, 2, negative 1, 0, and b equals, let me write b over here, 1, 0, 0, 0. Now, when you talk about matrices, you may be able to do what's called finding an inverse. It doesn't always work, but most of the time it works, okay? So we gotta watch out. We'll talk about when it doesn't work when we run into that. But for now, we're just gonna pretend that it always works, okay? So our inverse is A inverse such that A inverse A equals A inverse equals what's called the identity, which in this case, which is always ones along the diagonal. Not pretty because I think I did a little bit extra there. Try that again. There we go. There's our identity, okay? If it does have an inverse, then we can say X equals A inverse B. Okay, so let's do that with this problem. Okay, now we're going to do it using a computer algebra, or we're going to do that using, a online tool. Okay, so let me go to a new screen. Okay, let me go here to my stop broadcast. Okay, starting video, so don't get confused. Now I'm going to share my other screen. There's going to be like 8 of me on the screen right now. Okay. So now you're seeing Octave Online. This is something that you can look at any time. Okay, so this is something that you can get. You can also put Octave on your computer. I do have Octave on my computer, but it's just as easily you can find it on the web. It's open source. That means it is free for you to use. There's no strings attached. Okay, and let's go ahead and solve this problem in Octave. Okay, so I remember I have my A written down. So my matrix A was 1, 1, 1, 1. I put a colon there, or a semicolon. Can't remember which one's which. 1, 0, 0, 1, semicolon. 2, 1, negative 1, 1, semicolon. 1, 2, negative 1, 1. And then I'm going to write my A. So that's the matrix that we had before. Okay, and let me write my B. Now my B, I'm going to write it as what I called a column vector. Okay, so I'm going to use 1, semicolon, 0, semicolon, 0, semicolon, 0. And there's my B. Now I'm going to take, I think it's INV, inverse A, times B. And I get 0.333, 0.333, 0.667, and negative 0.333. So I'm going to interpret those as 1/3, 1/3, 2/3, negative 1/3. Okay, so I'm going to go back to my sheet. Where is it? Stop sharing. Stop video here. Share screen. Looking at my answer from before, so my answer from before was Okay, so I used Octave to do this. One third, 2/3, -1/3. So Octave's not the only tool, but it is a nice one. You can use it for free. It's available for you online. Beautiful. Okay. All right, we'll go ahead. We'll do another one. Well, we won't do another one. We're gonna do some. We're gonna come to it back to another video. All right. See you guys in the next video.